This is the EdExcel GCSE 91 Maths Higher Paper 1, and it's from the November 2018 series. Question number 1, we have to work out the value of 3 to the power of 7 times 3 to the power of minus 2 divided by 3 to the power of 3. Here we would have to use the laws of indices. We've got the law shown here. If we have a to the power of m times a to the power of n, so when we times with the same base, we add the powers, leaving us with a to the power of m plus n. Another law shown here, if we have a to the power of m divided by a to the power of n, that's equal to a to the power of m minus n. When we have the same base and we are dividing, we subtract the powers. And so, if we focus on what we have on the numerator, we have 3 to the power of 7 plus minus 2, and then we are dividing this by 3 to the power of 3. So on the top, we have 3 to the power of 5 divided by 3 to the power of 3, and now, because we are dividing with the same base, we subtract the powers. So we have 3 to the power of 5 subtract 3, which is the same as 3 to the power of 2, which is 9. So the value of 3 to the power of 7 times 3 to the power of minus 2 divided by 3 to the power of 3 is 9. Question number 2. We have v squared, which is equal to u squared plus 2as. U is 12, a is minus 3, s is 18. We have to work out a value of v for part A. Well, with our value of u, a and s, we can substitute these into our formula to find out what v squared is, and from that we can then square root to find out what v is. V squared is equal to u squared, so that is 12 squared plus 2 multiplied by a, which is minus 3, multiplied by s, which is 18. And if we work out what this is, we have 144 subtract 6 times 18, which is 108. And so therefore, v squared is equal to 36. And then if we square root, we have v equaling the square root of 36, which is plus minus 6. So we can choose either of these, for example, v equals 6. And then for part B, we have to make s the subject of the formula, v squared equals u squared plus 2as. Well, if we have our formula, v squared equals u squared plus 2as, the goal is to get s by itself. If we subtract u squared from both sides, that leaves us with v squared subtract u squared equals 2as. And at this point, we can divide both sides by 2a, and the result of doing so is on the right hand side, the 2a's simplify to 1, and so therefore we have s equals v squared subtract u squared divided by 2a. So s equals v squared subtract u squared over 2a. Question number 3. A bonus of £2,100 is shared by 10 people who work for a company. 40% of the bonus is shared equally between 3 managers. The rest of the bonus is shared equally between 7 salesmen. One of the salesmen says, if the bonus is shared equally between all 10 people, I will get 25% more money. Is the salesman correct? You must show how you get your answer. Well, if 40% of the bonus is shared equally between the 3 managers, that means for the 7 salesmen, 60% is shared between the 7 salesmen. And so, if we consider the situation for the 7 salesmen, we can find out how much they have in total. We need to work out 60% of 2,100. Well, 10%, that's equal to 210. And so 60% multiplying 210 by 6, we get 1,260. And so therefore, 60% of 2,100 is 1,260. And this is how much all 7 salesmen have between them. And so we can find out how much one salesman has. For one salesman, 1,260 divided by 7, that's 180. Now, if they share all the money equally, we've got in total 2,100, and there's 10 people in total, so if shared equally, 2,100 divided by 10, that's £210 each. Now, what we need to do is calculate the percentage increase from 180 to 210. And we're checking if that equals 25%. So, the percentage increase, 210 minus 180 over 180 times 100 would be the percentage increase, and if I work this out, we have 30 over 180 times 100, which is 16.6%. So this is the percentage increase, not the 25%, which was claimed, and so therefore, the salesman is incorrect. Question number 4. It would take 120 minutes to fill a swimming pool using water from 5 taps. For part A, how many minutes will it take to fill the pool if only 3 of the taps are used? Well, we know that it takes 120 minutes if 5 taps are used. So, for 1 tap, if here, for 1 tap, well, for 5 taps it takes 120 minutes. So for 1 tap, it will take 5 times longer. So if here, we divide by 5, that means I would have to multiply by 5. It takes 5 times longer to fill 1 tap. And so therefore, for 1 tap, it takes 600 minutes. And what we need to do is find out how long it will take for 3 taps. Well, this will be 3 times less. So I need to do 600 divided by 3, which is 200. So for 3 taps, it would take 200 minutes. And then we have to state one assumption we made in our working to the answer in part A. Well, we've assumed that all taps have the same flow rate. Question number 5. A plane travels at a speed of 213 miles per hour. For part A, we have to work out an estimate for the number of seconds the plane takes to travel 1 mile. Well, the time it will take, we've got here 1 mile because that's how far we are travelling, and the speed is 213 miles per hour. And so what the time is then would be 1 over 213 hours to travel 1 mile. And what we need to do is find out how many seconds this is. Well, if we have hours, minutes, and, well, we've got hours, minutes, and seconds. To go from hours to minutes, we times by 60. Minutes to seconds, we times by 60 again. Seconds to minutes, we divide by 60. And minutes to hours, we divide by 60. So I need to multiply by 60 and then 60 again to convert this hours into minutes. So I've got 1 over 213 hours and what I need to do is times this by 60 twice to convert this into seconds. And if we do that, what we end up with is 3,600 over 213 in seconds. And so what this is approximately equal to is 3,600 over 200 seconds, which is 18 seconds. So it takes approximately 18 seconds. And then for part B, is the answer to part A an underestimate or an overestimate? Well, because we have rounded the 213 down to 200, it would then be an overestimate. Question number 6, we have to solve the simultaneous equations 5x plus y equals 21 and x minus 3y equals 9. Well, let's rewrite the equations. We've got 5x plus y equals 21, that's equation 1, and we've got x minus 3y equals 9, that's equation 2. What you will notice, if I take a look at the y's, the coefficient of y's are not the same, ignoring the signs. And so we can get the coefficient of y's the same by multiplying equation 1 there by 3. And if I do that, I've got 5x times 3, which is 15, x, y times by 3, which is 3y, 21 times 3 is 63. Let's call this equation 3. And because the coefficient of y is the same, and we've got opposite signs, we can add equation 2 and 3. So if I do equation 2 plus equation 3, x plus 15x is 16x, 9 plus 63 is 72. So I've got 16x equals 72, x is therefore equal to 72 divided by 16, and if I work out what this is, well, I have 9 over 2, which is the same as 4.5. So when x equals 4.5, I can now substitute into either equation to find out what y is. Let's substitute into equation 2. We have 4.5 minus 3y equals 9. We have 3y, which is equal to 4.5. And so y would equal 4.5 divided by 3, which is the same as 1.5. So I've got a solution of x equals 4.5 and a solution of y equals 1.5. Question number 7. The diagram shows a square ABCD with sides of length 20 centimeters. It also shows a semicircle and an arc of a circle. AB is the diameter of the semicircle and AC is an arc of a circle with centre B. We have to show that the fraction area of shaded area over area of square is pi over 8. First of all, we can find the area of the square. We've got sides of length 20 centimeters, and so the area of the square then is 20 multiplied by 20, which is equal to 400 centimeters squared. We can now find out the area of this quarter circle, and so the area of the quarter circle, well, we've got pi times by the radius. Now the radius will be 20 squared, but then we have to divide this by 4 because we've got a quarter of a circle. And so if we work this out, 400 over 4, that's 100, and then timesing by the pi, the area of the quarter circle is 100 pi centimeters squared. We can now find the area of this semicircle. The area of the semicircle, well, the area of a full circle, that's pi r squared, but the radius here will be half the diameter, which is 10. So I have, for the area of the semicircle, pi multiplied by 10 squared, but then I need to divide this by 2 because I've got half a circle. And so 100 divided by 2, that's 50, timesing that by the pi, we have 50 pi centimeters squared. So now for us to find the shaded, well, I've got the square, and then I need to equate this. Well, actually, we could take the area of this quarter circle and take away the area of the semicircle. And so the shaded area, we've got the quarter circle, 100 pi, take away the semicircle, 50 pi, and it turns out we get 50 pi centimeters squared. And so therefore, what we require is shaded over the area of the square. So we have 50 pi, and then this is being divided by 400. So if I work out what this is, we get pi over 8. And that's exactly what we wanted to show. Question number 8. For part A, we have to write down the exact value of tan of 45 degrees. That quite simply is 1. Next, here is a right angled triangle. We are given that cos of 60 is 0.5, and with this we have to work out the value of x. Well, cosine corresponds to the adjacent of the hypotenuse. We've got the adjacent for the hypotenuse as x, and so we have the cosine of 60 degrees equaling 4 divided by x. So I've got 0.5, and that's what the cosine of 60 is. That's equal to 4 divided by x. And so therefore, x is equal to 4 divided by 0.5. 4 divided by a half, that's 8. And so therefore, x is 8. Question number 9. The times that 48 trains left a station on Monday were recorded. The cumulative frequency graph gives information about the number of minutes the trains were delayed, correct to the nearest minute. So we've got the delay in minutes and the cumulative frequency. The shortest delay was 0 minutes, the longest delay was 42 minutes. For part A on the grid below, we have to draw a box plot for the information about the delays on Monday. Well, if we were to draw a box plot, what we need is information about the median, the lower quartile, and the upper quartile. Now, what we have altogether is 48 trains. And so halving the 48, that's 24. So for me to find out the median, I need the 24th number. So I read across and then I read down. It turns out the median is 10. Now I need to find the lower quartile. That will be 1/4 of 48, which is equal to 12. So I find where 12 is, that's over here, and then I read across, and then I read down, and it turns out the lower quartile is 4. And then I need the upper quartile. That will be 12 times by 3, or 3/4 of 48, which is 36. So I find 36 and then I read across and then I read down, and it turns out the upper quartile is 20. Now I've got the shortest delay, 0 minutes, and then I've got the longest delay, which is 42 minutes. So I've got the shortest delay, that's equal to 0, and then I've got the longest delay, that's 42. So now we've got enough information to plot a box plot. So I've got the shortest delay, that's 40, well that's 0, so I show that over here. Then I've got the lower quartile being at 4, so that is over here. And then I've got the median at 10. And then I've got the upper quartile at 20. And then I've got the longest delay at 42, so that is over here. So now we join all of these up like so, and then we join the quartiles like this, and here is our completed box plot. And then for part B, 48 trains left the station on Tuesday. The box plot below gives information about the delays on Tuesday. And what we have to do for part B is compare the distribution of the delays on Monday with the distributions of the delays on Tuesday. Well, here is Monday, we'll call this 1 for now. And then we've got Tuesday, we'll call this 2 for now. So now, if we compare the medians, we can see that the median for Monday is greater than the median for Tuesday. So we've got the median delay on Monday, which was greater than the median delay on Tuesday. And if I compare the interquartile ranges, well, what I can see from here is the interquartile range. I'm going from here to here, so I've got from 4 to 20, that's 16 for the interquartile range on Monday. And for Tuesday, the interquartile range, I'm going from 6 to 14. So from 6 to 17 rather, that is 11. So we can see that the interquartile range on Monday was greater than the interquartile range for Tuesday. So the interquartile range on Monday is greater than the interquartile range on Tuesday, which means that Tuesday had a more consistent pattern of delays. And then for part C, Mary says the longest delay on Tuesday was 33 minutes. This means there must be some delays of between 25 minutes and 30 minutes. Is Mary right? Give a reason for your answer. So Mary's not right because there may be no delays between 25 and 30 minutes. So she's saying that there's no delays between 25, well, rather what she's saying is that there's only delays between 25 and 30 minutes, but in fact we could have delays between 17 minutes and 25 minutes, or delays between 30 minutes and 33 minutes. So there may be delays between 17 minutes and 25 minutes, or 30 minutes and 33 minutes. So between 17 and 25 minutes, we might have some delays, or between 30 minutes and 33 minutes, we may also have some delays. Question number 10. For part A, we have to simplify x minus 1 divided by 5 times x minus 1 squared. Well, here, the x minus 1 cancels with the squared term once, and so what we will be left with over here is 1 over 5 times x minus 1. So we have 1 over 5 times x minus 1. And then for part B, we have to factorize fully 50 minus 2y squared. Well, the numbers that are common to both is 2, and then inside the bracket we would have 25 minus y squared. And then if I recognize that I've got a difference of 2 squares here, we have 2 times by 5 plus y multiplied by 5 minus y. And so we end up with 2 times 5 plus y times 5 minus y. Question number 11. Jack and Sadia work for a company that sells boxes of breakfast cereal. The company wants to have a special offer. Here is Jack's idea for the special offer. Put 25% more cereal into each box and do not change the price. Sadia's idea is reduce the price and do not change the amount of cereal in each box. Sadia wants her idea to give the same value for money as Jack's idea. By what percentage does she need to reduce the price? Now, because we are considering value for money, to work out value for money, we've got the price percentage over the cereal percentage, and we want this to be the same. So if I consider the amount for Jack, he's saying do not change the price, so the price for him will still remain as 100%, but he's saying put 25% more cereal in, so the cereal percentage, that's 125. Now for Sadia's percentage, we don't know what that is, we'll call that x. But then she's saying that the amount of cereal remains the same, so we'll say that the amount of cereal is 100. And what we need to do here is find out what x is. Well, 100 divided by 125, that is 4/5, and that's equal to x over 100, and clearly then x will equal 80, because I've got 4/5 times 100, which is x. And so if she has 80, that means she's reduced it by 20%. Question number 12. We've got A, B and C, which are points on the circumference of a circle with centre O. DAE is the tangent to the circle at the point A. The angle BAE is 56 degrees and the angle CBO is 35 degrees. You have to work out the size of the angle CAO, showing all of your working. So first of all, we can see over here that OA and OB are both equal to each other because they are both radii. So because they are both radii, because we are going from the centre to the circumference, that means the triangle AOB is isosceles. Now, because we've got a tangent meeting the circle exactly once, that means that we have 90 degrees here. And so the angle OAB we can find out by doing 90 subtract the 56. So the angle OAB, that's equal to the 90 degrees minus the 56, which was given, and it turns out we get 34 degrees. So we have 34 degrees here. And therefore, well, let's write down the reason for that. The tangent meets the radius at 90 degrees. And because base angles in an isosceles are equal, that means this angle here is also 34 degrees. It's the same as this angle here. So OBA is 34 degrees, and that's because base angles in an isosceles are equal. Now we can find out what this angle here is. Recognizing that angles in a triangle add up to 180, we have the angle BOA, well, we want the minor one of this, that's equal to 180 subtract the 34 subtract the other 34, and it turns out here we would get 112 degrees. So this angle is 112 degrees, and the reason for that, angles in a triangle sum to 180. Now we can find out what this angle here is. So the angle BOA major, that will equal 360 minus the 112, which is equal to 248 degrees. So we have 248 248 degrees here, and the reason for that is because angles around a point sum to 360. Now, what we can do is find out what BCA is, which is this angle here, by recognizing that the angle at the circumference is half the angle at the center. So, BCA, that's equal to the 112 divided by 2, which is 56. So we have 56 degrees here, and the angle at the center is twice the angle at the circumference. Now we want the angle CAO, which is this angle over here. So the angle CAO, that's equal to 360 minus the 56 minus the 248, and then we subtract the 35 as well, and it turns out the angle CAO is 21 degrees. So this angle here is 21 degrees, and the reason for that is the angles in a quadrilateral sum to 360. And so therefore, the angle CAO is the angle we want, that's 21 degrees. Question number 13. We have to describe fully the single transformation that maps triangle A onto triangle B. Well, to do this, match up the corresponding corners. So this matches up with this. This would match up with this. And this would match up with this. And then we've got our center over here, 2, 2. And what we can see is the shape is getting smaller by 3 times. So we can see this length here is 6, and the corresponding edge here is 2, and so the scale factor will be -1/3 because it's also rotating with it. And so when we come to describe fully the single transformation, we have an enlargement scale factor -1/3 with centre of enlargement 2, 2. Question number 14 for part A, we have to work out the value of 16 over 81 to the power of 3 over 4. Well, what this is the same as is taking the 4th root of 16 and dividing this by the 4th root of 81, and then raising this to the power of 3. So we have the 4th root of 16, which is 2, 4th root of 81, which is 3. I've got 2/3 raised to the power of 3. So that's the same as 2 to the power of 3 divided by 3 to the power of 3. And it turns out we get 8 over 27. So we have 8 over 27. And then for the next part, we've got 3 to the a equals 1/9, 3 to the b equals 9 times the square root of 3, and 3 to the c equals 1 over root 3. We have to work out the value of a, b, and of a plus b plus c. So, if I have 3 to the a equals 1/9, I can rewrite this, so I've got 3 to the a equals 1 over 3 squared. So I've got 3 to the a, which is equal to 3 to the power of minus 2. So 1 over 3 squared is the same as 3 to the minus 2. In which case we can see a is equal to minus 2. And then we've got 3 to the power of b equals 9 times by the square root of 3. So I've got 3 to the power of b equals, now 9 is the same as 3 squared, and then the square root of 3 is 3 to the power of 1/2. When I've got the same base and I'm timesing them, I add the powers. So I've got 3 to the power of b, that's equal to 3 to the power of 2 plus 1/2. So I've got 5 over 2. So I've got 3 to the b, which is the same as 3 to the power of 5 over 2. So b is equal to 5 over 2. And then I've got 3 to the power of c equals 1 over root 3. So I've got 3 to the power of c equals 1 over root 3. So 3 to the power of c is equal to 1 over 3 to the power of 1/2. So 3 to the power of c is equal to 3 to the power of negative 1/2. In which case we see that c is equal to negative 1/2. And so a plus b plus c, that's minus 2 plus 5 over 2 minus 1/2, and it turns out here we get 0. Question number 15. 3 solid shapes A, B and C are similar. The surface area of shape A is 4 cm squared. The surface area of shape B is 25 cm squared. The ratio of the volume of shape B to the volume of shape C is 27:64. We have to work out the ratio of the height of shape A to the height of shape C, giving the answer in its simplest form. Well, what we need to do in this question is find the ratio of the lengths. If I consider the ratio A to B, that ratio, well, I've got the surface areas equaling 4 cm squared and 25 cm squared. So if I square root those to find the ratio of the lengths, I have the square root of 4 to the square root of 25. And it just so happens this is 2 to 5. And if I consider the ratio B to C, I've got the ratio of the volumes being 27:64, so the ratio of the lengths in that case will be the cube root of 27 to the cube root of 64. And it turns out here we get 3 to 4. And what we want is to find the ratio A to B to C, which will allow us to find the ratio A to C. So if I find out the ratio of A to B to C, well, currently the B's aren't the same. I need to make them the same somehow. The lowest common multiple of 5 and 3 is 15. So I want 15 here, and I want 15 here. To go from the 5 to the 15, I times by 3. 2 times by 3 is 6. To go from 3 to 15, I times by 5. 4 times 5 is 20. So I have 6 to 15 to 20 as the ratio A to B to C. And therefore the ratio A to C is 6 to 20. In its simplest form, we have 3 to 10. So I've got 3 to 10. Question number 16. We have to prove algebraically that 0.256 recurring can be written as 127 over 495. Well, what we'll do is we will let x equal 0.256, 56, 56, etc. And if I multiply this by 100, because 2 digits are recurring, 100x, that's the same as 25.6 5 6 5 6 5 6, etc. And therefore, subtracting these, 99x will equal the 25.656, etc. minus the 0.256, etc. So these terms would cancel out. So we've got 25.6 take away 0.2, which is 25.4. X is equal to 25.4 over 99, which is the same as 254 divided by 990, which is the same as 127 over 495. So I've got x equals 127 over 495, which is what I wanted to show. Question number 17. Here is a sketch of a curve. The equation of the curve is y equals x squared plus ax plus b, where a and b are integers. The points 0, -5 and 5, 0 lie on the curve, and we have to find the coordinates of the turning point of the curve. Now what we need to do before anything else is actually find the values of a and b. We can do this by substituting the coordinates 0, -5 and 5, 0 into this equation. Now here we've got the we've got the coordinate 0, -5, and here we've got the coordinate 5, 0. So if I substitute in the coordinate 0, -5, x is 0, y is -5, we have -5 equals x squared, so that is 0 squared, plus ax, so that's a times by 0, plus b. So what we can see from here then is b equals -5. And if I consider the point 5, 0, then I've got 0 equals 5 squared plus a times by 5 plus b. Now I already know what b is, that's -5. So I've got 0 equals 25 plus 5a minus 5. So I have 5a, which is minus 20, a is minus 4. And now that I know the values of a, b, we can therefore conclude y equals x squared minus 4x minus 5. And what I need to do is find out the coordinates of the turning point. The turning point is over here. And for me to find the coordinates of the turning point, what would I have to do is complete the square. So if I complete the square, I have the coefficient of x, so that's minus 2, and therefore I would have x minus 2 squared. Then I subtract the square of 2, and then I subtract 5. So y would equal x minus 2 all squared minus 4 minus 5, which is minus 9. And so therefore the coordinates of the turning point would be 2 minus 9. So I have the coordinates here 2 minus 9. Question number 18. The graph of y equals f of x is shown on the grid below, and on the grid above we have to sketch the graph of y equals f of x minus 2. Well, here I've got the graph of y equals f of x, and what I need to do, if I think about how to go from y equals f of x to y equals f of x minus 2, well, let's write this down. From y equals f of x to y equals f of x minus 2, this would be a translation by vector 2, 0. So I've got this vector here, this curve here, I need to move it 2 units to the right, so I've got 1, 2 units to the right. And so therefore, here I've got the graph of y equals f of x minus 2. And then for part B, on the grid, graph A has been reflected to give the graph B. The equation of graph A is y equals g of x. We have to write down the equation of graph B. Well, if I think about where this graph has been reflected, graph A has been reflected in the y-axis to give graph B. So, from A to B, we have a reflection in the y-axis. And if I think about how we represent that, well, going from y equals g of x to y equals g of minus x, that would be a reflection in the y-axis. So I have y equals g of minus x. Question number 19. For all values of x, we know that f of x is equal to x plus 1 squared, and we know that g of x is equal to 2 times by x minus 1. And what we have to do is show that g of f of x is 2x times x plus 2. So for us to work out g of f of x, that means I take my graph g and then I input into this f of x, which means I replace the x with x plus 1 all squared. So I have 2 multiplied by x, which is being replaced by x plus 1 squared, and then I have the minus 1. So I have 2 multiplied by x squared plus 2x plus 1 minus 1. So I have 2 times by x squared plus 2x, and if I factorise out an x as well, I have 2x times by x plus 2. And that's exactly what I wanted to show. And then for part B, we have to find the inverse of g of 7. Well, finding the inverse of g at x equals 7, that is the same as solving g of x equals 7. And so if I know what g of x is, that's 2 times by x minus 1, and that's equal to 7. So I have x minus 1 equals 3.5. X is therefore equal to 4.5. Question number 20, we have to show that the square root of 18 plus the square root of 2 all squared divided by the square root of 8 subtract 2 can be written in the form a times b plus root 2, where a and b are integers. Now what we'll do to begin with is we'll deal with the root 18 plus root 2 all squared. Now root 18, well, what this is the same as actually is root 18 plus root 2 multiplied by itself. And so root 18 times root 18, that's just 18. And then I've got root 18 times root 2 twice. Now root 18 times root 2, that's the same as 18 times by 2, then square rooted. And then I've got another root 2 times root 18. So I'm adding on to this root 18 times 2, and then I've got root 2 times root 2, which is 2. So I've got 18. Now here I've got the square root of 36, and then another square root of 36, plus 2. So I've got 18 plus 6, plus another 6, plus 2. And it turns out here we have 20 plus 6 plus 6, which is 32. So how does this help us? Well, what we can therefore say then is the following. We've got root 18 plus root 2 squared over root 8 minus 2. What this will equal is, well, this is the same as 32 divided by root 8 minus 2. And now for me to simplify this, what I have to do now is rationalize. So for me to rationalize, I would have to multiply both the numerator and the denominator by the conjugate of the denominator. So I need to multiply top and bottom by root 18, rather root 2 plus 2. It's effectively the same as multiplying by 1. So I have on the top 32 multiplied by root 8 plus 2, and on the bottom we have a difference of 2 squares. Root 8 times root 8 is just 8, and then minus 2 times 2, that's minus 4. 32 divided by 4 is 8, so I have 8 multiplied by root 8 plus 2. Now root 8, that's the same as 4 times 2 square rooted, and then we're adding on 2. So I've got root 8 multiplied by root 4 times root 2 plus 2. So I've 8 times by 2 root 2 plus 2. And if I take out a 2 as a common factor, I've got 8 times by 2 times root 2 plus 1, which is the same as 16 times the square root of 2 plus 1. Question number 21. OAB is a triangle. OPM and APN are straight lines. M is the midpoint of AB. We're given that the vector OA is A and the vector OB is B. The ratio OP to PM is 3 to 2. We have to work out the ratio ON to NB. Now, we can find various different vectors over here before we do anything else. We can find the vector AB. If we were to find the vector AB, that's equal to the vector AO plus the vector OB. So we have minus A plus B as the vector AB. Now, because M is the midpoint of AB, we can therefore conclude that AM, which is the same as MB, that's 1/2 of AB. So I've got 1/2 of minus A plus B. So I get minus 1/2 A plus 1/2 B. And now what I can do, because I know what AM is, I know what OA is, I can find the vector OM. So the vector OM, that's OA plus AM. So the vector OA, I know that's minus A. And the vector AM, I've just found that to be minus 1/2 A plus 1/2 B. And it turns out here, we get 1/2 A plus 1/2 B. So I know what OM is. I can now find out what OP is, and I can use this ratio here. The vector OP, that's equal to 3/5 of OM. And that's because OP to PM is 3 to 2. So I have then 3/5 of 1/2 A plus 1/2 B. And if I work out what this is, it turns out I get 3/10 A plus 3/10 B. And what we can also do is find out what the vector PM is. That's 2/5 of OM. So I've got 2/5 of 1/2 A plus 1/2 B, which is 1/5 A plus 1/5 B. So I know what OP is, I know what PM is. Now, I need to find out what ON and NB are somehow, but I don't know those ratios. Now, if I think about AP is, because I can find AP because I know AO and I also know the vector OP, so with that I can find out what AP is. So the vector AP then, that's equal to the vector AO plus the vector OP. So I've got AO, which is minus A, plus the vector OP, which is 3/10 A plus 3/10 B. And if I work out what this is, it turns out the vector AP is minus 7/10 A plus 3/10 B. So how does this help us? Well, I know that AN is a straight line, and because AN is a straight line, AP would be a fraction of that. So AP is a fraction of AN. So let's write that down. If I write that down, we've got y equals, well, I've got y times by AP, which is equal to AN. What I'm saying over here is y is, well, AP is a fraction y of AN, and that's because APN is a straight line. So can we find out what AN is? Well, from A to N, I can go A to O and then O to N. So AN, that's equal to AO plus ON. So I've got AO, which is minus A, but now ON, that will be a fraction of OB. So I've got here x times by OB. So what does this x represent? Well, ON is a fraction x of OB, and that's because ONB is a straight line. So if I work this out, I've got here minus A plus x times by B, because the vector OB is equal to x. So how does this help us? Well, because I know that y times by AP is equal to AN, I know what AN is, I know what AP is. What I can therefore conclude from here then is y times by the vector AP, and the vector AP is minus 7/10 A plus 3/10 B, so we're using that idea given. That will equal the vector AN, which is minus A plus x times by B. And therefore, for me to find out what x and y are, we can compare components. So if we compare components, looking at the A component, we'll do this in green. What multiplies to give A? I've got y times by minus 7/10 A, that's equal to minus A. So I've got, if I take a look at the A components, I've got minus 7/10 y equals minus 1, in which case I can conclude y is equal to 7, rather y is equal to 10/7. And if I take a look at the B components, I've got y multiplied by 3/10 B, and that will equal xb. So if I take a look at the b components, I've got y times by 3/10, and that's equal to x. And because I know what y is, that's 10/7, that means I've got 3/10 multiplied by 10/7 equals x. So x is equal to 3/7. So how does that help me? Well, I can then conclude that an, that's equal to minus a plus x times by b. Now I know x is 3/7, so here I've got an equaling minus a plus 3/7 b. And I can also find out what ON is. ON, if we remember, that's x times OB. So ON is equal to x, which is 3/7 times by b. So now with this, I can find out what NB is. So the vector NB, that's equal to the vector OB minus ON. So I've got the vector OB equaling B minus the vector ON, which is 3/7 B. And it turns out the vector NB is 4/7 B. So I can now find the ratio ON to NB. So ON to NB, I've got 3/7 B to 4/7 B. So this ratio would simplify to 3/4. So the ratio ON to NB is 3/4. Question number 22. There are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. There are more than 12 pens in the box. Simon is going to take at random 2 pens from the box. The probability that Simon will take 2 pens of the same colour is 27/55. And we have to work out the number of green pens in the box. Well, we are finding the number of green pens in the box, so we will let the number of green pens in the box equal x. And therefore, for the number of blue pens, that will be x plus 3. And what we can therefore conclude then is the total number of pens will be x plus 3. The total number of pens is 2x plus 3. And we know that there are more than 12 pens in the box. So using this statement of there are more than 12 pens in the box, we can say from here then that 2x plus 3 is greater than 12. So because there are more than 12 pens in the box, 2x plus 3 is greater than 12. Now, if I subtract 3 from both sides, 2x is greater than 9, which means x is greater than 4.5. And because I need a whole number of pens, we have a minimum of 5 greens. We round the 4.5 up. Now, we know that the probability that we have the same colour, that's equal to 27/55. So, what this means then is the probability of a green followed by another green plus the probability of a blue followed by another blue is equal to 27 over 55. So now let's work out what x is given the information we know. So if I work out what this probability is, well, I've got 2x plus 3 in total, and green is x. I've got x out of 2x plus 3 originally. And if I take out one pen from the box, that means I would have 2x plus 2 left over. And if I take out one green after this, here I would have x minus 1. Now for blue, I've got 2x plus 3 in total. And of those, how many are blue? Well, I've got x plus 3 which are blue. And if I take out one from the box, 2x plus 2 would remain. And if I take one blue out, I would have x plus 2 blue remaining. And I know that this is equal to 27 over 55. So now what I need to do is combine these fractions. Well, I have x times x minus 1 plus x plus 3 times x plus 2 over 2x plus 3 times 2x plus 2. We've got a common denominator of 2x plus 3 times 2x plus 2. And I know that this is all equal to 27 over 55. So now if we simplify on the top, x times x is x squared, and then I subtract x. And then I've got here x times x, which is x squared. And then I've got x times 2, and then x times 3, so that's in total 5x. And then I've got 6. And then I'm going to divide this by 2x plus 3 times 2x plus 2. And the result of this is 27 over 55. So, if I simplify on the top, I have on the top 2x squared plus 4x plus 6 over 2x plus 3 times 2x plus 2. And the result of this is 27 over 55. Now, what we can do is factorise out a 2. So on the bottom, I've got 2x plus 3 times by 2 times by x plus 1. And on the top, I can also factorise out a 2, so I've got 2 times x squared plus 2x plus 3. And the result of this is 27 over 55. Now, happily for us, the 2's here cancel. And what we'll do is we'll expand along the bottom. So along the bottom I've got 2x times x, which is 2x squared. Then I've got 2x times 1, and then 3 times by x, so that is 5x. And then I've got 3, and on the top I've got x squared plus 2x plus 3. And this is all equal to 27 over 55. So now if we cross multiply, we have 55 times x squared plus 2x plus 3, and that's equal to 27 times 2x squared plus 5x plus 3. And now let's expand out. So I have 55 x squared plus 110x plus 65 by the plus 165, and that's equal to 54x squared plus 135x plus 81. So if I take everything over to one side, that means I have x squared minus 25x plus 84 equals 0. Now, what I need to do over here is solve this equation. Well, I need two numbers which multiply to give 84 and which add to give minus 25. Those two numbers, we've got minus 21 and minus 4. So when I come to factorise this, I would have x minus 21 times x minus 4 equals 0. So if x minus 21 is 0, that means x is 21, and if x minus 4 is 0, that means x is 4. But we also know that x is greater than 4.5, and that's what we saw over here. We need a minimum of 5 greens, and therefore x is equal to 21 only, and so what we have then is 21 green pence.